Graphs of circles. We're starting with circles where their center is at the origin, that is 0, 0. We will look at further translations of circles as well. This is the easy one. If we have a circle with the center 0, 0 and radius r, let's just pop in a radius there. You'll notice this looks an awful lot like the unit circle. Here is point P with the coordinates x, y. This is the y value. Here we have the x value, and those are at right angles to each other quite obviously, and this is the radius. That radius gives us that relationship between x and y, which is of course from Pythagoras' theorem. So x squared plus y squared equals the radius squared, and that is the form of a circle when its center is at 0, 0. If you rearrange to make x or y the subject, you'd want, of course, y equals plus or minus the square root of the radius squared minus x squared, or x is plus or minus the square root of the radius squared minus y squared. As you'll see, if I have an x value, then solving to find y will give me two different options. This makes sense because the graph has two different values of y at this value of x. It's got one here and one here. So the basic things that we had to learn, of course, is just the parts of a circle. So this nice easy one. The only thing that's likely to trip you up is you really must remember that this is x squared plus y squared equals the radius squared. The radius is not 4, it's the square root of 4, which is 2. Because there's been no transformations to this circle, the center is 0, 0, the origin. The radius is the square root of 4, which is 2 units in this case. And if you're asked to sketch the graph of a circle showing the intercepts, absolutely all you need to do is draw a little table of value, draw a set of axes, and mark the same distance out on all 4 axes. Carefully draw a circle that goes through those points as accurately as you can, and the intercepts are going, 2, 2, -2, and -2. X and Y, label the rule, and you've graphed that circle or sketched it. So showing the intercepts is very easy, and make sure your circle is nicely curved. Just as an extra little option here, find the values of y when x is 1. X squared plus y squared equals 4. Or, of course, you could use the rearranged version, which is y equals plus or minus the square root of the radius squared minus x squared. Either one will work, you'll just have to rearrange this one yourself. So y is plus or minus 4 minus 1, so y is plus or minus the square root of 3. You've done that. It's pretty easy. Circle transformations. These are our old friends h and k. When we start moving our circle around, instead of just having x squared, we could have x plus or minus a value, same with y. So when we are given a circle such as this one, it still gives us the radius squared. The transformation is, as you can see, we've got x minus h, and hk gives us the centre, so it will be the opposite sign of whatever is in here that gives us the coordinates of the centre of the circle. So if I'm asked to sketch a circle when I've moved it, sorry, I'll just pull my example page up in my textbook here. Where was I? Sorry. So, when we're asked to sketch a circle, start with working out where your centre point is and be very aware of where that is in relation to your axes, because you can get really carried away doing the working out for intercepts and then find out that you didn't have to do it at all. So, our centre is hk. We take x minus h, so if it's minus 2, that means h is 2, and y minus k, so if it's plus 3, that must be minus negative 3. So our centre is at 2, negative 3, and our radius, this is the radius squared, square root of 9 is 3. A good idea when you're doing a circle to stay fairly accurate, so I'd probably consider putting in some evenly spaced gradations, even possibly with a ruler. So my centre is at 2, negative 3. My radius is 3, which means I'm 3 down from the x-axis here. This is my x-intercept here at 2. You don't need to go finding any other x-intercepts because the circle is only going to come up that far. It will go out, of course, over to about here, and so working to find these intercepts would be required. You can draw your circle in as accurately as you can, which is not very accurately at sometimes. Mark the coordinates of your centre, and then of course you would need to find your x-intercepts. You'd go back to the rule of your graph, and you'll solve for x equals 0 because you want your y-intercepts. Did I say x-intercepts before? I'm sorry. You want your y-intercepts. So that is substituting in 0 minus 2, so that's negative 2 squared, plus y plus 3 squared equals 9. So I've got 4. Taking that away from both sides there means I've got y plus 3 squared equals 5. Y plus 3 equals, take the square root of both sides, plus or minus the square root of 5. So y equals plus or minus the square root of 5 minus 3, or of course negative 3 plus or minus the square root of 5. And this will mean that I have negative 3 plus root 5 and negative 3 minus root 5 as my intercepts, very poorly drawn. Label x and y, and label your graph with its rule. So this is very definitely a 10A concept here, but our standard circle with, or an extension, sort of B grade or A grade, something, can't remember, And your standard circle is, of course, quite basic C-grade core work.